Hey guys, welcome back. We're here for lesson 118 today. So today we're going to talk about estimating area. So far when we talked about area, we have talked about formulas for finding area of regular shapes. So shapes like a circle, we know that to find the area of a circle, we would use the formula A equals pi r squared, okay? Or we could be finding the area of a rectangle, in which case it would be A equals length times width. Or we could be finding an area of a triangle, which would be area. Remember, a triangle in relationship to a rectangle is half. So we can always remember that that means we do the same thing, which base times height is the same as length times width for a rectangle. Base times height divided by 2. And remember, those base and the height always have to intersect at the right angle, okay? So just a little area review, because actually we're not going to use any of these formulas today because we're not finding exact area today. We are just estimating area. So today what we're going to look at is what happens when we're given a shape that's not regular. That's not one of these regular figures. How do we find the area then? Okay, so what we are going to see is that we can actually put it on a grid to kind of help us estimate by calculating boxes. Sounds weird, but once I show you, you're going to be like, oh, okay, I see what they're going for here. So let's just go ahead and open this little picture up. So if we've got a 1 acre grid, so we're saying this grid represents 1 full acre of land, okay? And it's placed over an aerial photograph. That means a photograph that's taken from above, from like a helicopter or something, of a lake. Estimate the surface area of the lake in acres, okay? So obviously this lake is not a regular shape. It looks like some form of a like sloppy, chubby triangle, kind of, but it's rounded at the edges. I don't even know how to describe that. Kind of looks like a block of cheese, and now I'm hungry. So anyway, something like that. So what we have to do though is we have to identify, really we're just going to try breaking it down into whole boxes that are inside and partial boxes. Okay, so anywhere inside that we have a whole box, that's automatically going to count as one whole acre, okay? So we'll say this is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9. So those are all the whole acres that are inside of the lake, okay? But we see that there's still all these other little pieces that are shaded as well. So each one that looks like about a half, like this one, we're just going to put a dot in because it represents a half. So half, half, half. That one looks like about half. That one looks like about half. And then down here at the bottom, it's a little bit harder to tell. These kind of look like, I guess these two look close enough to a half, but then I would almost say that this one, and this one could all go together to make one. Like those are more like thirds, if that makes sense, okay? So let's count up from there. So we had 9 holes, okay? 9 holes, plus 1, if we count our dots, 1, 2, 3, 4, 5, 6, 7 dots, okay? So each of those represents a half. So if I've got 7 halves, think about 6 halves would be 3. So 1 more half would be 3.5. So I've got 3.5, we'll say there, okay? And then plus the ones where I colored in and said those are all about a third, that makes up a total of 1 acre. So then all total here, if we add all those up, we've got 13.5 acres. Okay, now again, this is an estimation. So if you're close to that, but not exactly, like as long as you're right there, pretty close, then we're good, okay? Because it's not asking you, there's no one right answer here. It's not asking you to solve using an exact formula and get an exact answer, which we do a lot of times, but not in this case. And you can know that because of the word estimate. If you see that word estimate, you know, okay, I'm trying to get close, but there's not an exact number that they're looking for here, okay? So that's it. Just go through and number the ones where you've got whole boxes, dot the ones where they're halves, and just kind of use your judgment if something doesn't really look like it would make up a half, but maybe 3 of them together could make up a whole, okay? I think of it like blocks, like trying to put blocks together, if that makes sense, to where they would fit, like Tetris. If any of y'all played Tetris. Anyway, you can totally think about it that way and it'll help. So, all right, this was a short one, but you guys got this. Go do your homework. Bye, guys.